All right, so on this, in chapter number 17, number 14, we got a problem where the probability of successfully hitting a bullseye with an arrow is 80%, so Q is going to be 20%. Okay, and we're doing problem 14. So number 1 says our first bullseye comes on the third arrow, so that means that we would get failure, failure, success. So that would be 0.8 times 0.8, which is 0.8 squared, times 0.2. And if we do that, then we're going to get 0.032. Let me zoom that in a little bit. There we go. Number 2. Sorry, part B. Part A, part B. She misses the bullseye at least once. Okay, well, she's getting 6 shots, so the probability that she misses at least once. Well, how do we do at least once? At least 1 is always 1 minus the probability of not missing. Okay, well, what's the probability that she doesn't miss? Well, the probability that the person doesn't miss is 0.8 to the 6th. So it's 1 minus 0.8 to the 6th, and that's 0.738. Part C. Her first bullseye comes on the 4th or 5th arrow. Okay, so we're looking at the probability. First success is on the 4th, or first success is on the 5th arrow. So the probability that the first success comes on the 4th arrow would mean failure, 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 success, or the 5th arrow would be failure, 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 success. So the probability of failure is 0.2 cubed times 0.8, or means plus 0.2 to the 4th times 0.8. And if we add those two together, we get 0.00768. Okay. Part D, she gets exactly 4 bullseyes out of 6. Okay, so 4 bullseyes out of 6. Probability of exactly 4 bullseyes out of 6 is 6 choose 4. 4 bullseyes, 0.8 to the 4th, 0.2 squared. Okay, and the way that we would do that is we would evaluate that using binom PDF. So we go binom PDF, precisely 6, comma, 0.8, comma, 4. And you should get 0.24576. Part E, she gets at least 4 bullseyes. Okay, so at least 4 means that 4 or more. So that's the probability of 4 plus the probability of 5 plus the probability of 6. Well, what does that equal? That equals 1 minus the probability of what's not over here. Well, 0 to 3. So we got to do the probability of 0 all the way up to the probability of 3. Well, what does that for us? What does this calculation for us is binom CDF. So I'll show you how to do that in a minute. So what do we have to put on our paper? The probability of 4 is 6 choose 4, 0.8 to the 4th, 0.2 to the 2nd, plus dot, 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 all the way up to 6 choose 6, 0.8 to the 6th, and then you would put 0.2 to the 0 if you want. And then we say, okay, well, I want to do at least, so I do 1 minus binom CDF. I'm shooting 6 arrows with a 0.8 chance of them being successful, and I want it to add up to 3, because that's what I'm going to subtract. I'm going to subtract from 1 the sum of 0, 1, 2, and 3, those probabilities put together, and I get 0.90112. Okay, and then the last one is F. She gets at most 4 bullseyes, so at most is the probability of 0, all the way up to the probability of 4. And the way we're simply going to do that, we don't do 1 minus, it's simply binom CDF. So the probability of no bullseyes is 6 choose 0, 0.8 to the 0, 0.2 to the 6th, all the way up to 6 choose 4, 0.8 to the 4th, 0.2 to the 2nd. And all I'm going to do is simply stick that in the binom CDF. So binom CDF, 6 comma 0.8 comma 4. And that binom CDF will add from 0 to 4 for me, and I get 0.34464.